This course focuses on statistical methods, as the name implies, is biostatistics, and we are looking on how to apply statistics in biological courses, actually, including biotech. So previously, we have two separate courses, Stats 1 and Stats 2. But this time around, biostatistics, it combines that two courses, Stats 1 and Stats 2. And having said that, is the LU actually is quite a lot, I can say. So please pay attention on, especially on LU2 and LU3. Yeah, LU2 and LU3 are a bit heavy, because LU2 is previously covers all the topics in Stats 1 previously, and LU3 covers all the topics in Stats 2 course, but we combine it, so it's quite I can say it's quite heavy course lah, I can say. So I hope that you can bear with it and you are ready mentally and physically for the course, okay? All right, so what else? The synopsis, it acquaints students with the assumption required for the validity. Yeah. So basically it's about the statistical techniques in biology. Okay, I hope that's clear. So previously I asked you to watch the recorded lecture 1 and 2 and have a look at lecture notes 1 and 2. I think this is very introductory, I can say. It's just to introduce you some basic concept, what is biostats. Yeah, just go through, yeah. But I'm not going to go that really detailed. So it's just to introduce you, to refresh your understanding on statistics. Yeah? You have learned statistics somehow in the past during your matriculation or during your high school, is it? Have you? Have you guys?
In my diploma, yes.
Yes, huh? Okay. I hope that you have some basic understanding on statistics, okay? So you have to familiarize on certain few terms, the few terms that we will refer to frequently after this. For example, population, sample, parameter, data, statistics. Population means it covers bigger coverage of data or bigger coverage of maybe data sets consisting of sample inside it. For example, Malaysia is a population. Sample is the states like Negeri Sembilan, Malacca, Johor, right? Those are samples because it is under the same under the population of Malaysia. Okay, so that's examples of it. Parameter is something that describe the characteristic of the population. Okay, let's say you are talking about population, Malaysia population, and you want to maybe investigate the trend of reading among the Malaysians. So the trend of reading is the parameter, because that is the thing that maybe you want to look for, you want to know more. So normally parameter is the variable of interest. Yeah, it could be vary from one research to another research, from one study to another study. Okay, but the general name for it is parameter. Data is whatever the information that is used in statistics, pieces of information we normally call data. The data, it can be quantitative, it can be qualitative. Quantitative refers to number, like you have numerical numbers, but you can also have non-numerical data. For example, the traits, the qualities. For example, you can say male, female, right? I mean the traits of maybe certain things, the traits of, like in biology or in biotech, the characteristics of the morphology, the morphology of, let's say, bacteria under the microscope. We cannot, sometimes we can count the number of cells, but other data we also want to describe it, whether it is what's the shape. whether it's rod shape, spherical shape, something like that. So that sort of quality is qualitative. So, but it's also considered as data, right? Statistics in general is described as numerical summary of many data. Yeah. So when we say that statistics, it means that there are lots of things, there are lots of information in it, but we say it as statistics. Okay. All right. So that's just to revise certain terms. Okay, types of data, I've mentioned about it. Quantitative, qualitative, yeah. It's very easy. Actually, quanti is quantity. Yeah, it's something on values, numbers. Okay, qualitative is on quality. And then two components of statistical analysis. There are descriptive statistics, inferential statistics. Descriptive statistics it comes from the word describe. Yeah, so means that it's something to give on description. Descriptive statistics means that it describes the trend, the current trend of the data. Okay, whereas inferential statistics, it's something related to forecasting. Like you have the data, but you want to use that data for forecasting, for estimating something in the future. For example, if we want to talk about weather forecasts, right? Of course, the meteorologists, the people who are expert in meteorology, they have certain types of data, but they use the data to predict, right, the weather of tomorrow, the day after tomorrow. So that sort of statistics is inferential statistics for forecasting, and also for maybe like for in economics, like to forecast the economic growth, things like that, probabilities. So that's inferential statistics. Okay, so I hope you're clear about it. Just some more explanation on that, and then there are also some revision. What are median, mean, median, mode? So those are the terms that we use quite a lot in statistics. Mean, average. Yeah, average and mean is the same, but normally we call mean. Yeah, median is the middle value. Yeah, if let's say you have a set of data and you have like maybe different patterns of the data, and if let's say you arrange the data from the lowest value to the highest value, so the middle value or the middle data is called median. Mode is the most frequent score. Yeah, mode is the most frequent score. Okay, how to find mean? I'm sure that you know already. This is very, very easy. Okay, it's just that you have to familiarize with the symbols. So for example, here we have X, and you have you notice that there is a, we call it bar. Yeah? So X bar is the mean, sample mean. Yeah. Okay, there are two types of mean: sample mean and also population mean. Yeah? Remember just now I give you an example of Malaysia as a population, states as samples, right? So if we talk about the mean of, let's say, just now the trend of reading among the mean of, yeah, the mean value of the, maybe the number of hours Malaysians spend on reading for Malaysia. So when we talk about Malaysia, we are talking about the population mean. But if let's say we want to know the mean of the sample, maybe the samples here are states, right? Like for example, Sarawak, Sabah, Johor. So it has its own mean value, isn't it? Like every sample has its own mean value. So it's different from the population mean. But of course, the sample mean, it will contribute to the population mean. Yeah, but they are two different things. And then apa lagi ni? Mean for frequency data. Oh yeah, we have this type of data. We call it, if you have a look at this scattered data. So this is what we call ungrouped frequency data. Ungrouped, they are not grouped. Whereas on the right hand side here, you can see that the data are grouped. So we call it group frequency data. Okay, that kind of data. So in order to find the mean, yeah, you have to apply different you have to apply this formula, but actually the concept is the same. Like for this one, basically, if you want to find the mean, you just sum up everything divided by the number of the data, isn't it? Like n refers to the number of the data. But here, okay, when you have the group frequency data, so you have another information here where we have class. Means that it means that this data is arranged according to classes. Yeah. So for example, from 1 to 10, how many data are exist? Actually, is it from here? Don't know, it's different. Yeah. So this one from 1 to 10, there are 2 data. The frequency is 2, and so on for the rest. So how to find the mean? So you have to multiply the mid value. You have to open it. You have to include the mid value here. The mid value of the class multiplied by the frequency divided by the number of the frequency. So that's how you find the mean of the group frequency data. So that's what is meant here, mean for frequency data. But if you think logically, like how you want to find, you can actually, I mean, not to say that you have to rely on this formula, but at the same time, you just have to think logically how to find the mean, okay? So without this formula also, you can know how to find the mean, right? So it's something that you have understood the concept, the mean concept. Mean for relative frequency distribution, what is this? Oh yeah, this is just to, okay, let's say you have just now this frequency, the group frequency data, for example, just now the classes and the frequency. When we insert another term here, relative means what you do is like, okay, now you have, like, this is the original data, and the n, the total n here is like 3 plus 1 plus 8 plus 10 plus 7 plus 7 plus 4 is equal to 40, right? Yeah. And then the relative frequency is when you divide the value of the frequency for every class with the n. For example, 3 divided by 40, you get this 0.075. And the same thing goes for the rest. Okay, so that's how you got relative frequency. And if let's say you want to check whether it is really correct or not, the value that you calculate for each of the class, when you sum all of this, it must be equal to 1, because it must be equal to 100% actually. Now this one you convert into percentage, 0.075 is equal to 7.5%. Okay, so that is meant by relative. It means that you are actually analyzing the value of every class like this, like the value of every class with the total number. Relative means something you compare with. Yeah? Something you compare with. A median, the middle value, I think is, yeah. If let's say you have, there are 2 situations for median, whether you have a data set of even numbers and uneven numbers. Even numbers is even numbers are 2, 4, 6, 8. Nombor genap, nombor genap. 2, 4, 6, 8, 10, 12, and so on. Odd is 1, 3, 7, 9. Okay. So if let's say for odd values, odd number of data is very simple because if let's say you have 5 data set, of course the one that sits in the middle is the third one, isn't it? Like you have 5, 1, 2, 3, 4, 5. So it's odd. So in the middle is 5. But if let's say you have 6, the one in the middle is 3 and 4. So you have to, this one is meant by here. Okay, so for the odd is straightforward. For the even, you have to sum the values in the middle, the two values in the middle, and divide by 2. So that will give you the median value. Yeah, it's only that for the median that you have to take note. Mod is the one with the greatest frequency. Okay. 1 mod, 2 mods. Okay, so sometimes there are certain distribution or data sets that have more than one mod. So it means that there are two values that have two similar frequency. So for that, that's called bimodal. 2 mods, 3 mods, trimodal. More than 3 mods, multimodal. Okay, so it's just the terms that you have to take note. Okay, what else? I think you go through by yourself for that one. A measure of dispersion. This one is we are concerned with the range, variance, standard deviation, coefficient of variation, skewness. Okay, range is the range from the largest to the smallest. Variance, so it's defined as the average of squared deviation scores. Means that if let's say you have a collection, a data set, you want to actually measure first the difference of squares. Oh yeah, first you have to measure the difference between, let's say, scribbles. Hold on. Yeah, like this one. So if let's say you have a set of data, 2, 3, 7, 5. Yeah, the mean is what? 2, 3, 5, 5, 7, 12, 12, 5, 17, 17 divided by 4, 4 point. Lagi example variance ni tadi. 17 divided by 4 is 4.25. Okay, 4.25. So if you see back the definition of variance just now, variance. Okay. The average of squared deviation score. Okay, average deviation score means that deviation from the mean. Maknanya, if let's say you have this one, two, like each of these, you treat 2 minus 4.25. How much? And then this value, you square it, okay? 3 minus 4.25 equal to ni. I don't have to look for the answer. 7 minus 4.25 square, and 5 minus 5.25 square. Okay, this value you add up, that's give you the variance. Okay, that's the variance. Means that they want to know how much the deviation from the mean of this data. Standard deviation is the square root of the variance. This is standard deviation. Okay, standard deviation. And then, apa lagi tadi? So that's the variance. Okay, the symbol is that sigma. Okay, sigma. This is what we call sigma. This one, this sigma. Okay. Okay. Apa lagi tadi? Standard deviation is the square root of it. And there are two types of variance, population variance and also sample variance. Ya, sama macam mean. Ya. Dia ada two types of variance. Okay, so there are certain formulas for variance. One is for the sample variance, and then for group frequency data, for relative frequency data. Okay, so you have to identify the symbol in order to use the formula. Okay, I mentioned about standard deviation just now is the square root of the variance. So you cari square root, then you get the standard deviation. Coefficient of variation. This one is apa ni? A measure of relative variability is denoted as the ratio of the standard deviation to the mean expressed as a percentage. Okay, so this one is the S is standard deviation. X, the one in the denominator, X bar, that one is the mean, the mean of whatever the sample. So means that they want to know like how much the deviation per the mean value times by 100. Okay, so that is the coefficient of variation. So this one are the parameters that that describes the dispersion. Maknanya macam dia nak this measure of this is like a parameters that describe if let's say we have a data, the dispersion means like how dispersed the data is. For example, like from range, we know that it's from 10 to 20. Okay, that is the, you know, like the range, yeah, the limit of the data. Variance just now is like to describe how much it varies from the mean value, that value, each of the value of the data. Okay, and the same thing goes to the rest. Okay, skewness, the last one, skewness. Skewness is like how we describe the data. So for example, if let's say we have the data, whatever the data set, for example, a few data set lah, let's say, I don't name it, and let's say we want to see how the distribution is. The distribution in statistics or in maths refers to how is the pattern of the whole data. Okay, so normally we will kind of like plot it and see whether, you know, like for example, if let's say we have between the range of 10 and 20. So how much is the data? If let's say it means that the pattern of the data, whether it's towards 20 or whether it's towards 10, something like that. Okay, but this is what we call distribution. Okay, this is another term that you have to take note in statistics. When we say distribution, it's the pattern of the set of data. So when we have, so when we talk about distribution just now, sorry. So we have this kind of skewness. Skewness is like the measure of how the distribution looks like, whether it is to the left or to the right. Okay. So for example, if let's say you have this one, skewed left. Skewed left, it is when it is said skewed left means that you can see the peak is actually to the right. See the peak here, the mode. This is what we call skewed left. So and then the other way around, skewed right means it is the peak is on the left. Okay, so that's the thing that you have to take note. Yeah? So in this case, for example, so what does it mean? The peak here refers to the values, the mode values, right? The mean always refer to the median value. And you can see that the position of the mean median is different. Like for example, here the mean and median is less than the mode. And for the second situation here, the median and the mean, the mode is actually less than the median and the mean. Okay. All right, so those are the basic concepts that I suppose you have covered in the first lecture, okay, as covered by the recorded lecture that you have watched. Okay, now let's move to lecture notes 2. So this course, if you see LU2, LU2 focuses on non-parametric statistics. Okay, non-parametric statistics, and LU3 focuses on parametric statistics. So what is the difference between non-parametric and parametric data? So it's mentioned over here. Non-parametric means that when there is no information or less information about the population, meaning to say that we can't, when we have no information about the population, we cannot make much assumption, or we cannot make even no assumption at all about the population. Okay, it's something like, if let's say you have some no information about something, of course you cannot assume anything, isn't it? So that kind of data, that kind of statistics, I mean, when we talk about statistics, it's called non-parametric statistics. Okay, so that's the difference. Parametric is the other way around. When you have more information about the population, means that you can make assumptions about the data, right? And normally in when we talk about data, when we have, let's say, more information, how to say that? Okay, so when let's say we have information about the data, and another condition is that when the number of the data is a lot. Okay, let's say we have just now I give an example of like the reading trends among Malaysians, right? Let's say I have information about it, and my data number is high. Let's say I have 10,000 of respondents. I have 10,000 data, okay, of the whole population. So it's a lot. So it means that at the end, that kind of big data, that kind of huge amount of data, it will generate certain trends, certain distribution that looks very typical, and that is how to say it, distribution yang senang nak bukan senang, distribution sorry, it will actually, the data will actually give me the distribution that I expect. Okay, how to say that, for example, okay, let's say I have just now 10,000 of data again. Okay, and my parameter is number of hours Malaysian spend on reading. Reading per week. Okay. So let's say my population just now is Malaysia. Population is Malaysia. Okay. So this kind of 10,000 data in statistics, normally if let's say the number is huge, at the end it will give a typical kind of distribution whereby the distribution will look like a bell shape. What is meant by bell shape here? Let's say the number of hours, the range here is like, let's say per hour per week. Logically, let's say 1 hour lah, yeah? And then until 10 hours. Okay, that is the range of data that I collected, yeah, from the people of Malaysian. Yeah. So means that from 10,000 ni dia akan bagi typical range di mana on average maybe ramai yang akan spend dekat maybe around 4 to 6 hours. And tak, actually is very small population yang akan spend dekat 10 hours. And very little also will spend on 1 hour. This is a trend that this what we call this a bell-shaped trend, or we call it normal distribution. Okay, this type of this type of distribution, bell-shaped or normal curve or normal distribution, is a typical distribution that is observed in data yang especially yang data yang banyak, data yang banyak. Sebab dia kebanyakan dia semua distribution kebiasaannya kat tengah-tengah ni yang banyak. Contohnya, kalau this one is like number of hours. Let's say during a grade meeting, whenever we have this, you guys have final exam, and after your final exam we mark, and then we discuss during the meeting before we release the marks. So when we analyze the results of the students, contohnya yang dapat A, contohnya untuk certain course, ada tapi tak ramai, mungkin dalam let's say 3 to 4 students. Let's say this is about let's say the students is 100 students. Yang fail pun tak banyak, mungkin adalah seorang dua, let's say. Okay, but the majority will sit in the middle, which is around antara B lah actually yang paling average. So that is actually the typical trend kat mana-mana distribution. And the statisticians, they have observed this. So itu yang actually they conclude as normal distribution, and they put it under actually under parametric statistics. Okay, jump back to here. So when you say here, information about population is complete for parametric. Information is known, completely known, and specific assumptions are met regarding the population. So that assumption normally is the normal distribution, I mentioned just now, because it's actually based on many observations. It's actually based on, I can say, millions of observations. It's not just from one case. Okay, so that makes the statistician conclude that parametric data ni dia akan membentuk that normal distribution. Okay, I hope you understand, or maybe you understand better later after you cover both topics. Apa lagi? The test statistics based on distribution. Test statistics arbitrary. So basically you can see that the comparison between non-parametric and parametric. Non-parametric, we don't have much information. Sometimes we cannot make assumption, and you can see here test statistics is arbitrary, whereas parametric we have certain things that we are sure of. So that makes us confident to make certain assumption. Okay. Back to both. Okay, and in conclusion, non-parametric is concluded as not as powerful as parametric tests because of a lot of uncertainties. Okay, so those are the things that you need to know between parametric and non-parametric. Don't worry, you will understand better when you go through both topics later. So this is just to introduce you what we will cover. For non-parametric tests will be covered in LU2. Parametric tests will be covered under LU3. Okay, so those are the types of tests. We are going to deal with lots of tests, statistical tests. If you see the list of tests here, and each of that tests, it will have its own procedure. Okay, so you have to basically you have to understand. You will see the similarities later, but basically you have to know how to do the test. You have to know how to perform the test. Okay, I think this is the same points. Okay, that's it for the last modules that you should cover. Okay, now today we're going to, I've gone through your answers for the forum. Thank you for the participation. Yeah, the answers are very good. So basically, I could see that you know what's the importance of statistics in biotech, even though we are in biotech, and biotech looks like it's not a mathematic field, but somehow you need statistics because you need to analyze the results that you have, the results from the biotech research, and that's why you need biostatistics. So that's why it's introduced in the first year so that you can apply it for your research, especially for your final year project. Yeah. So a simple example of statistics is you calculate mean, calculate standard deviation. Yeah, that one is very very basic for any field. Okay, let's have a look at the module that we have to cover today. So the last two modules, they are in LU1, which is the introduction. Okay, so it's not much. LU2 is a bit lengthier, is much lengthier than LU1. So we're going to cover in few weeks. Okay. So for this week, we are going to cover the first subtopic of LU2, which is Sine Test. Okay, Sine Test. So the rest we will cover in the following weeks. So for today's lecture, we're going to have a look the introduction to Sine Test, and then one sample Sine Test, paired sample Sine Test, and then some information on left tail, two tail, and extra notes when n is greater or equal to 25. Okay, so Sine Test. So what is Sine Test? So basically in statistics, we want to compare. It's always the main business is we always want to compare the results with a benchmark or with something else. Okay, that is the basic idea of statistics in anything. Yeah. Okay, you want to make comparison. So you're gonna clear. Make a comparison. A comparison with what? It depends on your subject matter. If let's say it depends on your experiment. It depends. I cannot say any general things to be compared, but it depends on your situation. So having said that, okay, there are many tests that we can conduct, and how to know which test is suitable for different situation. We have to know first the nature of the test. So that's why we introduce you different types of tests, statistical tests. So now for this one is LU2 is non-parametric. So non-parametric is for data that is for data that we don't have much information, or the number of the data is not that high. Okay, when I say high here is like the statistician define the non-parametric data is less than 25, but there are some definitions, but it's like not much lah. Okay, if let's say is more than 30, that one is considered a lot. But for non-parametric data is for data that is very little in terms of the quantity. Okay, so Sine Test is the simplest, is one of the earliest and simplest tests. Okay, the reason why it is the easiest and simplest because remember when we make a comparison, for example, like we want to compare, contohnya number kan, 5 and let's say okay, let's say you want to compare score, your marks lah, contohnya I got, let's say 70, my marks for a course. Okay, so the benchmark ni contohnya macam the score that is used as a reference. Okay, for example, the faculty level, the benchmark is 80, let's say lah kan. So if let's say I just use Sine Test, okay, my marks is 70, the benchmark is 80, so it's less kan. So tapi dalam Sine Test ni, if let's say it's not just to compare one mark, it's let's to compare a set of data. you don't have to care about the magnitude. You just say, okay, 70, 80 is less. Maybe you got another person got 90, 90, 80. Okay, this one is plus. So we're just talking about the sign. So that's why it's called Sine Test. Okay. Now let's go through first. Later you will see what it means by all these sign things. Okay. The Sine Test is divided into one sample and paired sample. Okay. Remember just now we talked about this term sample. Okay. Sample, it means it's not only one data. One sample, it can consist of many data set. Okay, tapi dia adalah satu subset of population. When we say paired samples, this is one sample. Okay, you can see there are a few data, depends on the sample. When we say paired samples, paired sample is we have like a pair. Let's say this is pair 1, okay, and this is pair 2. Okay, no, pair 1. Sample 1. Okay, this is sample 1, sample 2. Okay, and then you want to, let's say, compare ni number 1, number 2, 2 dengan 2, 3, 3, macam tu lah. So that is called paired. Okay, so that's paired samples. So paired samples ni dia banyak untuk macam situasi, let's say before and after. Let's say reading of glucose level before taking medicine, okay, for a group of people. And then when the group of people are given certain medicine, what's the glucose level? So after, but it's still referring to the same group. They just want to know before and after. So that is a kind of examples of paired sample data. Okay. Sine test is a statistical method to test for consistent differences between pairs. Okay, between pairs. I mentioned just now, between pairs. Or if let's say you are talking about one sample, let's say one sample of student. Okay, and they are maybe 10 students. So they have their own score. Contohnya score untuk test 1. So let's say this one student A got 70, 50, 65, 80, 90, 82, 62, macam tu kan. So those are the data of that sample. Okay, and let's say remember that we want to make comparison kan. Comparison with what? Okay, normally if let's say for one sample macam ni, they will give you like one value that you want to compare each of the data with. Okay, for example, just now if I give a example of faculty benchmark score, let's say 80. So you want to compare lah dalam one sample ni, how the score of every student, how it differs with the benchmark with 80. But that one is an example. Okay, it can be different from one situation to another. But that's how the comparison is made. Okay, kalau tadi pair tu dia by pairs lah. Okay, so given pairs of observation, pre and post treatment for each subject, the Sine test determines if one members of the pair tends to be greater or less than. Okay. Positive sign is assigned to the data when it is bigger, and negative sign is assigned to data when it is bigger the value. Okay. Contohnya tadi, let's say the score dia kan 70, 50, 82, 65, 80, 62, 90. You want to compare with 80. So, okay, what is actually the ultimate aim of making comparison? You want to actually check whether the mean score of the sample, the mean score of this sample that has, let's say, 10 students, is it higher or less than 80? Itu dia punya objective, ultimate objective. Why we make a comparison? Because we want to know which one is better, which one is lower, how's the difference. Okay, So tapi the way how we compare to, because it's Sine Test, it doesn't care about the magnitude lah, magnitude. Okay, so that's why it's the simplest. Dia nampak mudah lah kan, sebab it's just considers the signs, but the disadvantage of this test is that it is not strong. Maknanya dia hanya bagi at the end macam the conclusion it can be made that okay, the score is higher than the benchmark values, but we do not know how much it is higher. Contohnya lah macam tu, because at the end conclusion nanti you akan tengok lah, conclusion dia akan cakap at the end of the test kita nak tengok sama ada score, the mean score ni tadi higher tak daripada 80 or lower tak. So it's by saying the in conclusion the mean is higher than 80, but how much, by how much, isn't it? So that's why it is not so strong. So this test is simple, is enough to give a picture about the comparison, but it's not as strong as other tests that we will discuss in the following weeks. Okay, but this is one of the tests that you want to cover lah. And the good thing about this test is that it might be useful in certain conditions whereby you may not need to know much about how much. Okay. Apa lagi yang you kena faham sini? I think if we go directly to the example, then it will be much clearer for you. Okay, so what are the steps? The steps for one sample Sine test. Okay, so every test yang you akan cover for this course, they are the procedure. Okay, there are step 1, step 2 until the last step. So step ni yang you kena faham, you kena hafal tak. Kalau you practice, you understand, you will know what to do. Okay, so basically apa yang persamaannya, what's the similarities of all the tests that you will cover after this? You will see that the common steps is the first step. They always akan state, I mean, you have to state the null and alternative hypothesis. Okay, that is the common things that you have to do for any test. Okay, and the last one is you have to make a conclusion. What makes the difference is the thing inside, how you analyze the data. Okay, how you analyze the data, and that one belongs to every is unique to every test lah. Macam Sine Test, these are the steps. Kalau nanti if you cover contohnya this one, will constant sign rank test, it has its own steps, but you can see that the first step and the last step will be the same. Create hypothesis, at the end make a conclusion. Okay, so conclusion tu yang sebenarnya yang the ultimate aim, sebab kita nak tahu apa, beza ke tak, ada beza ke tak, macam tu. Okay, right, so let's have a look at all the steps here. Do you know what hypothesis is? What is hypothesis? It's a bit sleepy, right? In the afternoon. Ngantuk. What is hypothesis? Ada orang ke ni? Kan semua dah tidur ni.
Hypothesis is like a theory before starting an experiment.
Yes, correct. Before you start any experiment, you must have some assumption, isn't it? Like what you think will be achieved. Okay, that's correct. Okay, alternative. So hypothesis. So hypothesis, we must have whether the statement is valid or invalid. Yes. So you must have two situations or two hypotheses, meaning to say that when you start experiment, you must have two assumptions, whether first there will be no change, maybe, or maybe another situation there will be a change. Okay, so hypothesis, when we say null hypothesis, null is something related to nothing happened or there is no change. Okay, so ia adalah hypothesis yang you akan set juga lah. And then we have alternative hypothesis. Okay, so null hypothesis H naught, the symbol is H naught. And for the alternative hypothesis is either H1 or HA. Kadang-kadang H1, both are correct. Okay, so that's the symbol. So that are the two hypotheses that you have to set. Okay, and then the second step is to decide the level of significance. This one normally will be mentioned in the question. Okay, normally mentioned. So the common values used is 5% or 1%. Okay, so why these values are important? Because you will use it somewhere later in the following steps. So if let's say it is mentioned in the question 5%, you just use 5%. But if it's not mentioned, you can define in your workout saying that by assuming the level of significance of either 5% or 1%, it's up to you. If that one is if it's not given. Okay, and the third step to determine the sign of difference between paired observations. Okay, this one I will show later. Determine the test statistics and which test distribution to use. Yeah, for these tests, you have to use table, which is called binomial table. So for every statistical test, there is a certain table that you have to refer. Okay, so for this Sine test, you have to refer a table called binomial table. So this table will be given in the exam. You don't have to worry about it, but it's just that you have to know how to use it, which one to refer, which column, how to read it. Yeah? So in this test, we use binomial table. Okay, step 5, compute the p-value and decision rule. Step 6, make a decision, okay, based on this decision rule. So these are the conditions. Means here, actually you got the probability of test statistics need from step 5 actually. This is actually 5. And this one level of significance is alpha. The symbol is alpha. So this one, you will actually the value that you got from step number 5, you will compare with the value of alpha. So that's why you need to know the value of alpha. So these two conditions that you have to refer in order to make decision. What kind of decision? Is whether to accept or reject the null hypothesis. Okay, which one that you will accept. Okay, contohnya kalau if let's say the probability of test statistics, if let's say the p-value is greater than alpha, then you accept the null, and the other way around. Last time when we have physical tests, this thing will not be given in the exam. This apa ni? Decision rule, you have to remember by yourself. So I will encourage my students last time to just remember one condition. For example, accept null hypothesis if p is greater than alpha. Only that, and automatically you know that if it is if it is opposite, it is the other way around. The reason why I ask my students to remember only one condition because I don't want them to mix up. Okay. So you just have to take note on that this decision rule. Okay, so after that, after you make decision, accept null or reject null, and the final step is to make a conclusion. So what is the difference between decision and conclusion? Conclusion you have to state in specific. Maknanya you have to of course when you set the hypothesis, it must be based on the certain a certain scenario that you are analyzing. So in the conclusion, you must state it specifically. I I will show it later. Okay, so those are the 7 steps in solving the Sine test. Okay, so this is the binomial table. So for this binomial table, okay, what you have to refer for this test is only this actually. P equal to 0.5. Okay, this P is different. This P is not the P, it's a bit confusing, I know, but this P belongs to the table. It's not the P that you are looking for in step 5, okay? So the step 5 here is actually the probability. Okay. Yeah, just keep it first, okay? Later you'll see how what all this thing means. Okay, let's have a look at one example to make it much clearer for you. The breaking strength of a certain kind of rope is tested giving the following results. Test whether these data indicate the mean breaking strength is more than 160 using alpha equal to 5%. Okay, so this data is given. So this is a sample, right? This is a sample. So it has 1, 2, 3, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data. And you are given a value of this. This is the benchmark that you want to compare your data with. And you are given alpha equal to 5%. You convert it into 0.05. Okay. So if you see the question, test whether these data indicate the mean breaking strength. So each of these is breaking strength. Good. So the ultimate aim is to see whether the mean of all these samples, is it more or less than 160? That is the objective of this problem. Okay. Right. So how to solve this? So basically you can see that this is one sample, right? That's how you relate it with one sample Sine test. Okay, so you can use Sine test to solve this. So let's apply all the steps here. Step 1, state the null and alternative hypothesis. Okay, so means how to write down the hypothesis. The null, so you are comparing with 160, and this one you call it mu, right? The mu, the mean, the mean. So for the null, you expect that there is no change or no difference between the mean and the 160. Means that it is the same. So the mean is equal to 160. Or you can put it in words like this also can, but if you want to make it more understandable for you, you can say that the mean breaking strength is equal to 160. Okay, no change. That's null. Alternative hypothesis. Okay, so basically we want to say that for alternative hypothesis is something that is contrary to the null hypothesis, which means that if you want to put it into equation, it would be not equal to 160. But in this question, you have to read properly. It's mentioned more than 160. You want to test only like one-sided. So this one, not equal, is actually, this one is two-sided. Two-sided. By default, it should be not equal to 160. But if let's say the question only asks one condition, more than, so you only consider one-sided. Means that instead of writing this, you just have to write more than 160. Okay? So sebenarnya this one lah yang alternatifnya. This one is actually the alternative hypothesis. Faham tak? If let's say it is not mentioned, if let's say the question, let's say I change the words, indicate the mean breaking strength is not equal to 160, then I can use not equal sign. But if let's say it's mentioned more than 160, then I use that accordingly lah. If let's say the question is less than 160, then I change it to less than. Okay, so it depends on the question. So you have to read the question carefully. Okay, so that is the alternative and null hypothesis. You can also put it in words. The mean breaking strength is more than 160 for the alternative hypothesis. So step 1. Step 2, what's the step 2? Okay, step 2 is quite straightforward. The level of significance is given, is 5%. Okay, you don't have to do much. Step 3, determine the sign of difference between paired observations. Okay, what is meant by paired observations here? We are comparing each of the data with 160. Okay, for example, 169 and 160, which one is bigger? 169, right? So we put plus sign. You see the steps, it says that determine the sign of difference between paired observation, assign a plus or minus sign to each of the value if it is bigger or less. Okay, so for example, 169 is bigger than 160, we put plus. 163 bigger than 160 plus. That's why it's called Sine Test. We just consider the sign. 165 plus this one. Okay, 160 and 160 is equal, so we don't assign any sign. Okay, so we just leave it. 189 and 160 plus 150 and 160 minus 169 and 160 minus this one plus this one no sign, this one minus. Okay, so at the end we have only 8, isn't it? 8 with the sign, 8 data with signs. So the n here, instead of, although the total number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 kan, tapi ada 2 yang tak ada sign, which is actually equal to the values. So we don't consider it in calculating the n. The n is 8, not 10. Okay, that one you have to be careful because you need that value of 8 ni for you to refer to the table later. Okay, so that is step number 3. See, if you see the, which one? Ignore those that are equal to mu. Which one? Which the one that doesn't have sign. Step 4, determine the test statistics and which test distribution to use. The rejection region is obtained from the binomial table with n equal to total number of plus and minus sign. Okay, what is meant by this step number 4? What you have to do is, okay, let's write down here. N equal to 8, number of plus is equal to 1, 2, 3, 4, 5, right? Number of minus is equal to 3. Okay, so what you have to find in step number 4 is you have to calculate the probability of event when it is hold on. When it is less or equal to 3 or PR equal to greater than 5. Okay, what does it mean here? Okay, 1, 2, 3, 4, 5. Okay, so that is meant by step number 4. Okay, sekejap. Okay, so here, if you see here, it's either one lah. Kalau let's say you tengok R less or equal to 3 tu dia lagi kurang. I mean, sorry, you don't have, okay, what you have to find here is PR equal to PR less or equal to 3. What does it mean? you have to find from the binomial table. Okay, remember just now I mentioned that you just have to refer to p equal to 0.5 because we are talking about two outcomes, positive and negative, plus minus. So that's the reason why we just refer to this column. Okay, but you also have to find things on the left here. Okay, remember the n, our n here is 8 kan, so we have to refer to this. So just now we are looking for PR is actually the event. We are looking for event less or equal to 3 or PR equal to 5. Remember? Okay, so yang ni lah paling senang sebenarnya. It's actually the same. I will show you later. So this one, it will be actually PR equal to 0 plus PR equal to 1 plus PR equal to 2 plus PR equal to 3. Okay, so because it's 3 and below kan. Okay, so these are the values that you should actually look for, because now we want to determine the probability. Actually P ni refers to probability. It's different from P kat atas ni. This one is probability. Okay, so you just take the values here. Like if you refer to 8, I hope you can see this table clearly. So this one 0.0039 plus 0.0312 plus 0.1094. It's referring to this one, R. R2 is this one, right? Okay, and R3 is this one. Plus 0.2188. Okay, so the values here, you sum up, you will get this one actually 0.3634. Tengok, these values are the same yang I mentioned tadi. Okay. Okay, that one is when you consider R less or equal to 3. Okay, let's say you want to find PR greater or equal to 5. Dia sebenarnya akan bagi value yang sama. Okay, contohnya kalau you refer back to the table, okay, you start with just now 5. So 5, you go here, this one, 0.2188, which is actually this one. 6 is this one, 0.1094. Kalau you tengok kat value ya. And then R7, 0.0313, which is sama lah ni. Plus 2, and the last one is 0.0039 for 8. So if you sum up, it's going to be the same. So that's why it's either one. Okay. So this value is the value that you will get after you solve step number 4. And that is actually at step 4 and 5 actually, because that's the p value, probability. So after step 5, you get the p value, and then you decide the decision in step 6. Okay, so now your value here is 0.3634, and you want to compare with your alpha value, which is 0.05. Okay, 0.05. So based on the decision rule, which one? Okay, the probability is greater than the alpha, isn't it? Which is you have to accept the null hypothesis. So that is the decision that you have to make. So step number 6, it means that you have to accept the null hypothesis. Okay, this is step number 6. Okay, and step number 7. So how you want to make a conclusion, you refer back to your hypothesis. Okay, accept null hypothesis. What is the null hypothesis? The null hypothesis says that the mean breaking strength is equal to 160, or you can put it in a way that there is no evidence that the mean breaking strength is more than 160, which is actually the same. Faham tak? Kalau you nak letak make it simple, also can lah. The mean equal to 160. Okay, so that is the conclusion. So you go back, if let's say you go back to your data just now, kan? So you want to actually make a conclusion of the mean with 160. Is it equal or not? That's why you analyze the whole data first. Okay, any questions? Anything that you don't understand in all the steps?
Good evening, Doctor.
Yes, good evening.
I have a question. Will you be uploading this lecture online later on?
Yeah, sure. Oh yeah, sorry. I should upload it before, right? Okay, sorry for that, yeah. Okay, so that is one sample test, one sample Sine test. Okay, do you need a break?
That would be nice, Doctor.
Yeah, okay, sure.
All right.
5 or
Thank
10
you.
minutes.
I'm
Do
not
you
too
want
sure.
5 or 10?
I think the rest of the group can participate. Either way.
Either way. 10 minutes? Or is it too long? Or you want to finish early? 5, eh? Okay, 5 minutes. Okay, so we continue at 3:50. Okay. Okay, can we resume?
Yes, doctor.
Okay, thank you. Okay, so just now we discussed an example of one sample problem, isn't it? Right, we have one sample and then we compare with a benchmark value. Yeah. So let's have a look at another example. Okay, let's have a look at I don't know why my camera is not. Let's have a look at paired sample, okay? Paired sample Sine Test. Okay. So the difference between one sample and paired sample is that for paired sample you have two samples where you want to compare those two samples. Okay, contohnya. Okay, so what are the procedure? Dia sama je. What are the difference is that you just have to make sure that the comparison is correct lah, from one point to another. Okay, so if you see the procedure, the only difference is that you have to consider the comparison and assign what is called D, where you want to assign the sign, yeah, okay, of the comparison. Okay, let's have a look at, and the rest of it is the same. Okay, because at the end you want to find the probability and you want to make a decision and you make a conclusion. So the rest are the same actually. So let's have a look at one problem. Okay. A restaurant is introducing a new recipe of fried chicken. The marketing department wants to know if the new recipe is tastier than the original one. The customers are randomly selected for a test. Each person is given a piece of original fried chicken to try and rates the test on a scale of 1 to 10. Okay, after drinking a glass of water, the same customer is given a piece of fried chicken cooked using the new recipe and asked to rate the taste using the same scale. Okay, so here is the data. So the one in the black font is the original data from the question. Okay, the one given in blue here is actually the workout, the part of the solution. Okay, so originally you only have this data, customer 1 to 10, the score, the rating for X and the Y. So this one is actually considered as one sample, and this is another sample. Okay, although if you look at the customer is actually the same, tapi kita nak compare this one side by side. Okay, so these are examples of paired samples, right? Now, the questions, let's have a look at back the question. The marketing department wants to know if the new recipe is tastier than the original one. Okay, so how we want to determine the alternative hypothesis. That is very important because this will help us to decide on the alternative hypothesis. Okay, so the steps are the same. First, we have to set the hypothesis, and then the alpha, is it given here? Alpha, it's not given. Okay, so this is an example of question that doesn't have the alpha value given. So you have to define by yourself. Okay, it's not given. Okay, alpha is not given. The level of significance. So you define itself, you define by yourself. Assume alpha equal to 0.05. So when you assume or you take the value, you must use the values that are typically used, like 0.05 or 0.01. Okay, don't assume other values than that, because these are the values accepted. So you cannot assume 0.06 ke 7 ke, tak boleh dah. You kena guna either 0.01 or 0.05. Okay. The new recipe is tastier than the original one. So this one is rating kan? Rating means like from the bigger, the higher, the bigger, the better, isn't it? So it means we want to say that the score of the mu y. Now we have, you have to assign mu lah, mu x, mu y, kan? So the hypothesis is step 1. The null hypothesis means there is no difference. There's no difference between the score between the new recipe and the old recipe. So means that the original score, mean, is equal to the new. Okay, the mean, in terms of the mean. Okay, for the alternative hypothesis, because it is mentioned in the question, the new recipe is tastier than the original one. So means that mu y should be greater than mu x. Okay, so that is the hypothesis. Okay, step 2 is this one. You have you define it as 0.05. Okay, step 3. What is step 3? Determine and tally the sign of difference between paired observations. Okay, so ni yang step 3 sebenarnya. Step 3. So you have to check the signs by comparing the pairs. So means if let's say you want to compare 9 and 3, 9 is bigger than, like now, okay. So the way how you compare, you must set the point of your comparison. For example, let's say you compare 9 and 3, means that, sorry, 3 and 9, so maknanya new recipe is bigger than the original. So you put plus minus. Okay, 5, no difference kan? 3 and 6 plus, because 6 is greater than the original. Okay, 1 and 3 also plus. So means that the source of the comparison should be equal at the same time for all. Okay, so 1 and 3 plus, 5 and 10 plus, 8 and 4. This one is minus, you see, because this one is less than the original, isn't it? 2 and 2 is similar. 5 and 8, that one is less than the original, so it should be minus. 6 and 4 plus, 7 and 6 plus. Okay, so that's how you got this sign of difference. Okay, so here we have to identify the n. The n is what? 1, 8, isn't it? Because the one that doesn't have this, we will discard it. And the one with signs, there are 8 signs. Okay, the number of positive is 1, 2, 3, 4, 5, 6. Number of minus is 2. Okay, so that is step 3. Step 4, you want to find the probability. Step 1.5, you want to find the probability, isn't it? The p-value. Okay, so now how we want to write the expression. We want to find the events. It's either one. So it means if you see 6 is actually a lot for you to list it down. So it's better for you to take the least number. So I would choose number 2. Okay, so means R is less or equal to 2. Okay, that is equal to P R equal to 0 plus P R equal to 1 plus P R equal to 2, isn't it? Okay, so when you look into the table, okay, we get the table, n equal to 8. Okay, so here, so this is the value that we are looking for, 0, 1, 2. Okay, so maknanya P just now equal to less or equal to 2 is equal to 0.0039 plus 0.0312 plus 0.1094. Okay, so the value is this one, isn't it? Berapa ni? Zero point zero. This one actually. Yes. So this one is 0.1445. So that's the p-value that we are looking for. So we have solved step 5. Okay. So step 6, we want to compare the p-value and the alpha value. Right. So the p-value and the alpha value, our alpha value is 0.05. 0.1445 is greater. So it means that this is the situation that we have to accept the null hypothesis, right? That's the decision, the conclusion. Making a conclusion, what is our null hypothesis? There is no significant improvement of the new recipe over the original one. Okay, so that is in terms of the sentence. So in terms of the expression, you can put all recipe is equal to the score, the mean score of the new recipe. So you're not simple, it can be in the form of expression. But this is for you to understand thoroughly what's the problem is. Okay, so this is paired sample. So you can see the steps are actually the same with one sample. It's just that now it involves comparison of the pairs. Okay. Any question? Not much after this. It's just few slides more. Okay. So just now, when you see just now, when you set the alternative hypothesis. Okay, this one. Even in the example before, this one is actually what we call. This brings to the next topic. Actually, this is one-sided. One-sided. We call it one-sided tell. Okay. So one-sided tell, it can be if let's say you have two things of comparison is greater or this one, or if let's say you have less, it's also called one-sided. But if you have mu y is not equal to mu x, this one we call two-sided tell. Okay, two-sided tell. So how it differs, how it will give a difference. So just now when we calculate the p, right? We just take the value of p as it is, because this one is one-sided, because our hypothesis is one-sided. But what happens if, let's say, the problem that we are analyzing, it falls into two-sided tell situation, okay? So you have to actually multiply the p-value with 2. Okay, so just now when we calculate the P just now, right? Mana P tadi? This one, this P. We just take it 0.1445 and compare with 0.05, isn't it? This is because this is one-sided tell situation. What is one-sided tell situation? Go back to the alternative hypothesis. It's only one sign just now, left or greater. Yeah. But if let's say you have a situation where you set your hypothesis, alternative hypothesis as not equal, yeah, not equal, how you want to set this is based on the problems. Yeah. So in that situation, this p-value you have to multiply by 2. Let's say here you multiply by 2. What's the value? 0.289. Okay, let's say p equal to 0.289. And only then you compare this 0.289 with 0.05. Okay, that is for double two-sided case. Okay, that's the difference. So that is actually is meant by left tell or two tell test. Okay, so I give you an example so that it is much easier for you to understand. So how to know? How to know? It depends on the problems that you are analyzing. Depends on the problems. Okay, so sometimes the problems will say directly that they want to analyze something more than or less than. Okay, but if the question how to know whether it's a two tell situation, the question will say that okay, let's go back to the question tadi kan. Okay, so the marketing department wants to know if let's say the new recipe is not equal to the original one. Let's say the sentence is like test here then is not equal to. So in that situation, that will give you an indication that your alternative hypothesis, you should use the sign not equal. Okay. So in that case, you have to multiply your P with 2. Okay. Go back to the first example just now. Yeah? Okay, this one. Test whether this data indicate the mean breaking strength is more than 160. So this one is one-sided. So if let's say in two-sided case, it would sounds like the mean breaking strength is not equal to or is different from 160, something like that. So these keywords is actually, it will give an indication or it will give you a hint for the alternative hypothesis and also your p-value. So that will affect the p-value. Okay, so that is for the left tell or two tell test here. So there are some more examples of problems that you can try by yourself. Okay, I don't want to go through that. Okay, the last part here. So extra notes on one sample Sine test when n is greater or equal to 25. So just now, if you see the number of data that we are analyzing, for example, in the first case, we only have 10 data, right? Okay, and the second example is we have 10 pairs, or when we consider the signs, we only have 8 pairs that we want to compare. But what happens if let's say we have the n is greater or equal to 25? Means that it is considered as the number is more or high. Okay, so for that situation, we have to approximate the distribution to be normal. Okay, that is what has been ruled out by the statistician. Okay, so what you have to do, you have to find the z value by applying this formula. So the n is the number of samples with the positive and negative signs. The r is the total number of positive signs. Okay, so once you got the z value, so what you have to do is you have to find what is the area that corresponds to that Z value? You have covered normal distribution, right? Somewhere, I think in Form 5, I still remember I studied normal during my admits. Betul tak?
Yeah, already.
Yeah, okay. So what you have to do next is when you know the Z value, you have to find what's the area enclosed by that Z value. Okay, for example, if this is the Z value, this is the area enclosed by it, and this is the tail area. You are looking for this tail area actually. This tail area, and then you want to compare this tail area, which is actually the area here is the probability. Remember the one of the concept in this one. So you want to compare it with which one? The decision rule tadi. Sekejap ya. I hope you don't get confused. Huh? This one. This one. This p value is actually, it will be your p value. Okay, but don't worry about that. The last part lah is normally tak ditanya sangat untuk Sine Test. We are focusing more on the early parts. That means you have to just focus on these steps lah. But that one is just for your information. Okay. So itu tak berapa sangat penting lah, I can say. But it's just for you to know what happened when n is greater than 25. Then you have to convert it to Z, and you have to find the probability under the curve using this table. Okay, right. I think that's it for this topic. Yeah, we have covered examples. So the rest are some examples. Some of them have the answer and some do not. So you can just practice by yourself. Okay. Yeah, there are some homeworks here. Any question for this module? Yeah, that's the end of today's lecture. I know it's a bit boring, but I don't have the choice. I just have to, yeah, you just have to bear with apa ni? With the boring lecture lah. Okay, sorry ya for that. Yeah, any question?
No, for me, doctor.
Okay, so we don't have any more, then we just disperse. Yeah. Any more for the attendance? Okay, so those who have scanned your QR code, then you can disperse, you can leave. Yeah, thank you for your attention. I'll see you guys next week, inshallah. Okay, stay safe, everyone.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor. Thank you, doctor.
Yeah.
Thank you and have a nice day, doctor.
You too. You too.